Okay, so today we're going to continue solving quadratic equations, but now we're going to do the quadratic formula. So we've solved by graphing, we've solved by factoring, we've solved by completing the square, and now we're going to do the quadratic formula, which is not new because you would have covered it in Algebra 1, okay? So your quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You're going to have to memorize that. I will not give that to you on the quiz or the test, okay? This formula is actually derived from taking standard form of a quadratic, so ax squared plus bx plus c. If that were equal to 0 and you just used your a, b, and c as your coefficients and you completed the square, that is how we get x equals all of this, okay? So your quadratic formula, all of that, even though it looks like a big formula, is derived from completing the square, okay? So what we're going to do, we're going to make sure that your equation is equal to 0. So last class we did completing the square. We didn't want it equal to 0. We wanted it equal to the constant because it was preventing it from being a perfect square trinomial. The quadratic formula, just like factoring, we want it equal to 0 because we're going to solve for our x, okay? Now, you can use quadratic formula on any quadratic. It will work for every single quadratic, whether it's perfect square or not, okay? What we're going to start with is by looking at it being equal to 0, and then we're going to state our a, b, and our c. And then also, I do the 4ac. You don't have to. Not every teacher does that, but I found out that it makes your work a whole lot neater if you go ahead and calculate your 4ac from this formula over to the side. Okay, so that's what we're going to do, and I expect to see that every time. Because if something happens in your work and you get a wrong number, I can usually try to backtrack it and look at what you multiplied if you got the wrong thing, okay? If you don't have it there, I can't fish around for partial credit, okay? So once you list those out, all we're going to do is plug it into the formula. So it's a matter of, can you list your the numbers, and can you plug it into a formula? Can you simplify radicals? That's majority of this, okay? So if I look at x squared minus 7x equals 18. I want to get it equal to 0. So I'm going to do what with this 18? I'm going to subtract 18. So that's going to give me x squared minus 7x minus 18 equals 0. And then I'm going to list over to the side. A is equal to what? B is equal to? C is equal to? Alright, then we're going to do 4ac. So 4 times 1 times negative 18 would give me negative 72. Okay, so what I'm going to do is I'm going to take x equals, I'm going to go ahead and set up my fraction bar. Now notice in your formula, the negative in front of the b is part of your formula. So I'm going to put b in parentheses whenever I plug it in for my first step, okay? And then also notice that you have a minus between your b squared and your 4ac term. So regardless of the value of 4ac, you're going to have a minus in between that, okay? So I'm going to have negative, and I'm going to plug in my b, which is negative 7, plus or minus the square root of. I'm going to have negative 7 squared minus, and then my 4ac is a negative 72. All over 2 times my a value, which is 1. Y'all good plugging that in? Okay. So then, I simplify. Negative 7 is going to turn into positive 7 plus or minus the square root of. Okay. Negative 7 squared is what? 49. 49 minus a negative is going to be 49 plus 72. Alright, so that's going to give me 121 all over 2. Okay, so then I'm going to check, can I simplify this radical. The square root of 121 is a perfect square, so it gives me x is equal to 7 plus or minus 11 over 2. Now remember, when you have your perfect squares, your radical goes away, so what do we always do after this step? We split it. We got to solve for the individual x values. So we've got x is equal to 7 plus 11 divided by 2, and x is equal to 7 minus 11 divided by 2. Alright, so 7 plus 11 is 18. 18 divided by 2 is 9. 7 minus 11, negative 4 divided by 2 is negative 2. So those are my two x values. Those are my two solutions. What do they represent? The x-intercepts. If I were to graph x squared minus 7x minus 18, it would cross at x equals 9 and x equals negative 2 for your x-intercepts. Okay? You can also check them. Take 9, store it for x in your calculator, type your x squared minus 7x, it should give you 18. Same thing for negative 2. Okay? Alright, so the next example, I've got negative 3x squared plus 4x minus 4 equals 0. With the quadratic formula, it is okay if your leading coefficient is negative. Okay? So here, it's already equal to 0. I'm going to list my values. So a is equal to negative 3, b is equal to 4, c is equal to negative 4. And then for AC, I'm doing 4 times negative 3 times negative 4. So you're going to have a negative 12 times a negative 4, which is going to give you positive 48. Okay, so I plug it into my formula. X equals negative, plug in your 4 for B, plus or minus the square root of 4 squared minus, plug in 48, all over 2 times negative 3. So then I'm going to simplify. I've got negative 4 plus or minus the square root of 4 squared is 16. 16 minus 48 is going to give me a negative 32 divided by negative 6. Okay, so we know that 32 is not a perfect square. We also know we have a negative underneath that radical. So what do we need to do for sure with the negative? Pull out the I for your imaginary part. Okay, now 32, I can simplify by doing my prime factor tree. That's going to split 2 and 16. That splits 2 and 8. 8 will split 2 and 4. 4 will split 2 and 2. So I'm going to have 2 pairs of 2 with a 2 left over. So I have x equals negative 4 plus or minus 4i square root of 2. Right? Because you got 2 pairs of 2 that are going to turn into your 4. Your I from the negative, and you're left with 2 underneath the radical all over negative 6. Okay, but I'm not done. Right? It's not in simplest form. What do I need to do? I have to take out the negative that's in the denominator, and I also have to simplify them. I can divide them all by 2. Okay, so really what I'm doing is I'm dividing these outside numbers. I don't ever change the radical. Okay, I'm taking those outside numbers and I'm dividing them by a negative 2. I'm going to take care of that negative in the same step I'm dividing by 2. Okay, so that's going to give me a positive 2 plus or minus 2i square root of 2 over 3. And that would be your answer in simplified form. Are y'all good with that? Okay. Okay, so if I have x squared minus 8x plus 16 equals 0, it's in the form I need it. So I'm going to list my values. A is 1, B is negative 8, C is 16. And then when I multiply 4AC, I've got 4 times 1 times 16. That's going to give me 64. So I have x is equal to negative 8 plus or minus the square root of negative 8 squared minus 64 all over 2 times 1. Okay, so I clean it up. X is equal to a negative 8 turns into positive 8 plus or minus the square root of. I've got a 0 there because negative 8 squared is 64. 64 minus 64 is 0 all over 2. Okay, well, what's going to happen when I have the square root of 0? It's just 0. So do I need 8 plus and minus 0 over 2? No. When this happens, you're creating a double solution. Okay, really a double root. So all I'm going to expect you to write is your 8 over 2, which is 4. Now, prior, we would always write ds for double solution, right? Right now, it doesn't matter if you put a ds or not, because we're about to look at discriminants and how many solutions there are. So really, the term solution can be interchangeable with roots and x-intercepts, and I don't want you to get confused by this being a double solution, which is really just one x-intercept, which is one real solution. Okay, so really what's happening is your x equals 4 is a multiplicity of 2. Okay, so it's okay if you don't tell me that it's a double solution right here. I'm not going to count off for that because it's really just a double root. Okay, but whenever you look at a graph, remember, I think I showed y'all what happens when you have a double solution. Maybe? Okay, so you would have something like this. So at 4, it would come down and touch it and come back up. So your vertex is that solution. Okay, instead of crossing it like it would with 9 and negative 2, it's just going to be the vertex touching your x-axis. Okay, I just don't want you getting confused with this and what we're about to do. Okay, so you can just put your 4 and be done with it. Alright, now the next example, I've got negative 6x equals negative 2x squared plus 11. It doesn't matter. With the quadratic formula, I said it was okay if your leading coefficient is negative. So it's up to you if you want to move the 6x over to the right or if you want to move everything over to the left. Either way, when you work it out, you should get the same final answer. Okay? I'm going to say I'm going to move this 6x over because I'm just going to move 1 instead of 2 terms. Okay? So if I do that, I'm going to have a negative 2x squared. I would have had to add that 6x plus 11 equals 0. So then my a is equal to negative 2, my b is equal to 6, c is equal to 11, and my 4ac, I've got 4 times negative 2 times 11, negative 88. So I've got x is equal to negative 6 plus or minus the square root of 6 squared minus negative 88. All over 2 times negative 2. So x equals negative 6 plus or minus the square root of, I've got a 36 plus 88, and that's going to give me what? 124, all over negative 4. Okay, so I need to simplify. I've got x equals negative 6 plus or minus. I've got my negative 4 in the denominator. I'm going to take my 124 2 and what? 31. Okay. So you get 2 and 62 and then 2 and 31. So 2 square root of 31. Alright? Can I leave it like that? No, I need to simplify. What am I going to simplify by? A negative 2. I've got to take care of the negative in the denominator, and I can divide all of them by 2. So my final answer would be x equals, I don't know if y'all heard him or not, but it's 3 plus or minus the square root of 31 all over 2. Y'all good with that? Alright, so that was solving using the quadratic formula. Now we're going to look at the piece that's underneath the radical. Okay, that b squared minus 4ac that's underneath the radical is called your discriminant. And that can tell you how many and what type of solutions you have. Now when I say solutions here, I'm talking about your x-intercepts. This is why I didn't want you getting confused with writing a DS for double solution a second ago, but then looking at what really happens with your x-intercepts here, okay? So the value of your discriminant, all we're looking at is the b squared minus 4ac. If it is greater than 0, so that means what type of number? Positive. So if your discriminant is positive, that means I would have taken the square root of a positive number. So this first example and this fourth example, and I get, even though this doesn't look like two separate answers, I get two answers, right? Two x-intercepts. So that gives me two real solutions. So when your discriminant is positive, you have two real solutions, which means you have two x-intercepts. Okay? When the discriminant is equal to 0, that's what happened right here, and I only got one number. And I already drew the picture of what it looks like. So when it's equal to 0, you have one real solution, and it just means you have one x-intercept, and that's your vertex. Okay? Now, if your discriminant is less than 0, meaning that it's negative, when you take the square root of a negative number, you always have to do what? Pull out the I, because it's imaginary. Okay? So if you look at the second example that we did, we had a negative under the radical, so a negative discriminant, and I ended up having two imaginary solutions. So that means if they're imaginary, I don't have x-intercepts. Okay? So if I look at x squared minus 6x plus 10 equals 0, you're only doing b squared minus 4ac, which you're going to have to memorize. When I say find the value of the discriminant, you're going to have to know it's just the b squared minus 4ac, okay? And so you're going to do three parts to it. You're going to plug everything in. We don't really need to do the 4ac. You're going to plug every number in. You're going to simplify each part, and then you're going to give me the value, okay? So if you want to label your a, b, and c, that's fine, okay, because I've got my negative 6 squared for b squared minus 4, my a is 1, and my c is 10. So that's going to give me 36 minus 40. 36 minus 40 is negative 4. So the value of my discriminant is negative 4. So how many solutions and what type would they be? I would have two imaginary solutions. Alright, so then I do x squared minus 6x plus 9. I label my a, b, and c. I'm going to have negative 6 squared minus 4 times 1 times 9. Gives me 36 minus 36, which gives me 0. I have one real solution. So the next example, all of these b's happen to be a negative 6. We've got a negative 6 squared minus 4 times 1 times 8. So 36 minus 32 is a positive 4. So if it's a positive 4, how many solutions do I have? Two real solutions. Are y'all good with that? Okay. So now we're going to look at the sum and product of roots. So if I were to just give you my two roots, which roots are the same as what? X-intercepts. Roots, solutions, zeros, x-intercepts, all the same, okay? If I were to just give you my x-intercepts, you could figure out what your equation is by going backwards, okay? So we're going to be using the sum and the product of the roots, which is our solutions, to write the equations. This right here, the sum of the roots is equal to negative b over a, and your product of the roots is equal to c over a. You're going to have to know the difference, okay? And remember, your goal is to get ax squared plus bx plus c, okay? Now, it's going to be an equation, so you should have y equals, okay? So write the quadratic equation in standard form that has the given roots. Okay, well sum, what are you doing with sum? What does that mean? You're adding. So for the sum of the roots, you're going to add them together. Whatever I give you, you're going to add them together. Okay, so I'm taking 3/4 and I'm adding a negative 12/5. Okay, well, they don't have common denominators. I need to make them have common denominators. So between a 4 and a 5, what would they be? 20. So 3/4 I need to multiply by what to get a common denominator of 20? So 3/4 will turn into 15/20. Now, we know a plus negative is really going to be a minus. All right, and I'm multiplying 12/5 by 4 to get that common denominator of a 20. So negative 12/5 turns into 48 over 20. So 15/20 minus 48/20 is going to give me, 15 minus 48 is negative 33. Okay? So my sum of the roots is negative b over a. So that's telling me that that negative 33 is my negative b. And that 20 is my a. Okay? Now when I do my product, what operation am I doing for product? Multiplying. I'm going to multiply 3/4 times negative 12/5. What's that going to give me? Okay, well my product tells me, my formula tells me the product of the roots is c over a. So that tells me that negative 36 is c and 20 should be a. Now, do my a's match? Yes. If they don't, you're going to have to manipulate them, get that common denominator so that your a is the same. Okay? So, my equation, if I know that it's y equals ax squared plus bx plus c, I know that my a is what? 20. So I've got 20x squared. Now this negative b is negative 33. So really b is equal to just the 33. So you're going to have to be careful with your b value. Okay, if you need to write out negative b is equal to negative 33 and divide by that negative 1 so that you visualize and see algebraically b is equal to 33, you can. Okay, so this is a plus 33x minus 36 for my c. If you want to list while you're working it out, a is 20, b is 33, c is negative 36, for you to see it and put it in your equation, that's fine too. Okay? Do we understand adding and then multiplying those? Okay. Alright, well what about whenever I have imaginary numbers? Okay, I've got a 7 plus or minus 3i. So what that means is I have my two roots, x equals 7 plus 3i, and x equals 7 minus 3i. So when I do the sum of the roots, I've got 7 plus 3i in parentheses plus my entire 7 minus 3i. Okay, so 7 plus 3i plus 7 minus 3i. I'm going to combine like terms, 7 plus 7. That's just 0. Your 3i and your negative 3i. Why do you think that's always going to happen? Like, that should always happen. Why? Because you're doing a plus and a minus and you're adding them. Okay? So when you're doing the sum, you should not end up with an I as your answer. Okay? So be careful with that. So if all I have is 14, but the sum formula tells me it's negative b over a, what do I need? Over 1. For me to recognize that that is negative b and that is my a so far. Okay? Now my product, I'm multiplying 7 plus 3i and 7 minus 3i. I got to FOIL it. So 7 and 7 is going to give me 49. Minus 7 and 3i is going to give me 21i. Plus 21i minus 9i squared. Y'all recognize what happens here? Did we have to FOIL that? Why not? They're conjugates. Does anybody recognize that? Okay, they're conjugates, so you shouldn't have to FOIL that. You should be able to go straight to 49 minus 9i squared, which my I squared is negative 1, so this is really 49 plus 9. Now I have a whole number again. I needed a fraction, so I'm going to put it over 1. So that's my C over A. Okay, so I should have y equals, my A is 1, so just x squared. Now, negative b is equal to 14, so what is b? Minus 14x plus my c, which is 58. Are we good with that? Okay. Now I want to emphasize what I was saying earlier. If you're doing something like you get 3 over 4 for your sum, but your product is 2 over 3. Well, if we know my denominator should be a each time, how am I going to have 2 values for an a? This is where you would need to get common denominators so you get the same a value. Okay? I don't know if you have that on your worksheet or not, but I want to go ahead and show you an example of that in case you do. Okay, so what would I get for my denominator? A 12. So I would need to manipulate those. Okay? Okay, you will have a quiz over this lesson, not next class, but the next. Okay? So y'all's will be next Wednesday. My gold day will be next Thursday. Okay?